Hello everybody, welcome to Bill Sky the Rust Guy, and today we're going to be talking about defining variables. Now that you have your Rust environment set up, and oh by the way, if you don't, you might want to go take a look at my Rust 01 and Rust 02 videos showing you how to set it up on Mac, Windows, and Linux. And the Rust 02 video shows you actually how to install it without having to download it and install that behemoth tool, Visual Studio. Now, you can install Visual Studio Code. It's completely different from Visual Studio. I wish Microsoft hadn't done that, but they did. But go ahead and get your environment set up, and then you can actually start running tools or developing tools using the Rust language. So let's just jump right to it. Okay, I have my Windows 11 here, and this is a very minimal Windows 11. I just have Rust installed using MSys. I did not install Visual Studio on this. I do have Visual Studio Code installed, and again, if you haven't looked at my videos on how to set that up, go take a look at those before you go here. I've got my Brave browser. I also installed Genie and the Genie add-ons, the Genie tools, but I haven't been able to get Genie to have the terminal up and running because with Rust you really want to use the cargo tool that lets you set up your package, set up your source file, and we're going to do all that today as well. We're going to do that many times in these videos. But I haven't been able to get it to work. I'm hoping to get it to work because Genie is a great tool on Linux, and in this Rust programming series, I'm going to be going back and forth between Windows and Linux because Linux is just, I feel, is a much better development environment. But there are those of you out there that want to just use Windows. I recommend that you don't do that. I recommend that you learn both Windows and Linux because it's going to make you more marketable in the marketplace. And in 2024, the IT marketplace, or I should say the programming marketplace, is getting rather saturated. So you've got to really stand out. So I really recommend you do both. So what I'm going to do here, I'm going to go into I'm just going to go and load a terminal, and I'm going to change directory to my documents folder, and I have a folder called Rust Projects, so I'm going to change directory to Rust Projects, and I already have a hello world there, but let's create a project which we're mainly going to use just for going over defining variables in Rust. So what I'm going to do is I'm going to say cargo, and I'm going to call this, I don't know, simple vars. And cargo, oh, that's interesting. Oh, I didn't say new. Oops, made a mistake. So you have to say cargo space new, and then your project name. And once you do that, you can see simple vars there. I'm going to change directory to simple vars. And now I can load up Visual Studio Code. So I'm going to say code dot, and Visual Studio Code will come up. It'll ask you, do you trust it? Yes, I always trust myself. And I'm going to get rid of my Python. Okay, so let's open up our source. So I'm going to expand src. I'm going to double click on main.rs, and there's our program. Now, what I do want to do here is I want to go up and I want to select terminal, new terminal. And you'll see I'm in the simple vars folder. I'm not in the src. I'm going to say cargo build. And this is how you do it in Visual Studio. I haven't found any kind of a tool that lets you automatically build that I trust. So I installed the parser, and take a look at my other videos on how to set this up. And this is how you do it. So I say cargo run, and we can see hello world. Okay, great. So now we actually have our tool up. Now I'm going to print ln program ending, just so I know that the program is actually ended, and also to get some practice. So I'm going to go ahead and save that. I could press Control S if I want. And I'm just going to go ahead and do the build again. Do the run. Okay, so my coding is working on Visual Studio Code. I added program ending, and everything looks great. So let's create our very first variable. Now, for those of you that may not have ever written a program before and you're doing it using Rust, the number one thing that you want to do, that you want to understand when you start writing a program, is what a variable is. And I've got all kinds of videos out there. There's all kinds of videos about what variables are. So I'm going to go over it really, really quickly. A variable is simply a place in your program that's going to store data. And that variable is only going to store the data for as long as the program is running. And Rust, Java, C, C++, COBOL, Fortran, they all use variables like this. And it's simply a way for you to store data that you're going to manipulate. Because when you write a program, the program is to get data, manipulate it, output it to the user or output it to a file. And that's what variables are. They're just little, I like to think of them as Chinese takeout food containers. Each variable is a little food container that's going to control your data, or that's going to contain your data that you're then going to manipulate it. In the case of Chinese food, which I love Chinese food, the objective is to eat it as quickly as possible. So, but think of it that way, or think of it just like a little box that's going to contain. Each variable is a separate little box, and those little boxes really don't have anything to do with each other unless your program wants them to. So that's a little summary of what a variable is. And in Rust, just like in C++ and C, you can define variables anywhere you like. However, I like to always define them up on top because the compiler is going to do that anyway. It's going to rearrange everything to put them up on top anyway. So I like to define all of my variables up on top. And there's some languages that you're required to put them up on top. You must put them up on top. Some of the older languages are like that. Some of the newer languages are like that too. But you always have to put them up on top. So what I find so interesting about variables in Rust is it's going back to the 1980s with Microsoft Basic, one of the very first languages that was a general purpose language that anybody could learn, called Basic, and then it morphed into Visual Basic, and it still exists in Visual Studio as a .NET language called Visual Basic. And the reason I'm saying that is because when you create a variable, you use the word let. And that was something that Microsoft came out with in their basic programming language. You give it the variable name. I'm just going to call this some variable. And then you make it equal to a value. Now in this case, some var is equal to 123. 123 doesn't have a decimal point. So this is going to automatically be defined as an integer, because there is no decimal point. I'm going to put a comment in here, an integer called some var. Now, comments are really important too. I mean, I actually should have probably led off with what comments are. A comment is a part of the program that the compiler that prepares your program to execute is going to ignore. It's there mainly for documentation. This is a single line comment. And actually, it's even a partial line comment because it starts at somewhere after the beginning of the line, and it starts with the two slashes. Now, if you want to do multi-line comments, first of all, this is a single line comment. If you want to do a multi-line comment / asterisk, and then you can have a multi-line comment. This is a multi-line comment. And what makes that a multi-line comment is the / asterisk. The / asterisk says start comments. This */ means end the comments. So anything in between those two set of characters or symbols is a comment. Now, what a lot of programmers will do is they'll put an asterisk at the beginning of each line of a multi-line comment. In fact, some editors will do that for you. In this case, it doesn't look like the Visual Studio Code did that. I'm going to press Control-C, and then I'm going to go down here and just build it, make sure my comments work. It finished, no problem. There's some warnings. We'll talk about that as we move forward in this language. So, back to variables. So I created a variable called some var. I'm going to change the name of that variable to some int var and just say 1 because we might want to create multiple. And I really don't recommend that you name variables like this. They should be named like the age, your age, year, quantity, pounds, anything, zip code, anything that actually defines the variable well and self-documenting. Now, that variable has the value 1, 2, 3. I want to create another one called some float var 1, and I want to make that equal to an actual floating point. A floating point variable. Now, what is the difference between a floating point variable? Well, from your point of view, a floating point variable is simply a variable that has a fractional component because you have the dot, the period, the decimal point 78 in this case. So that's going to assign some float var1 a floating point value, and some float var1 will always have a floating point value. Unlike Python, Rust is a strongly typed language. Now, notice we didn't specify a data type here. The compiler does that for us. It sees 1, 2, 3. It says it's an integer, so it's going to make some int var1 an integer data type. 456.78 is a floating point data type, so the compiler will make some float var1 a floating point variable as well. Now, you can't change the variable type. Like, let's say if I tried to move 456.78 into some int var1, it's going to chop off the .78, the decimal 78, because some int var1 is now a integer variable for all time, as long as your program is running. Okay, so what do we do with this data? Well, let's go ahead and let's print it. So I'm going to say print ln, and the first thing in print ln is always a double quote followed by the variable that you want to print. Now, come int var is not what I had, it's some int var1. Okay. Now, if you're going to be printing a variable after the double quotes, you have to put in the 2 curly brackets. Now, the video after this will be all about printing data in a Rust program. And so we're just going to do the basics here. So what these 2 curly brackets mean is that I want to put something into the double quotes, and in this case, I want to put the value of some int var. Let's do it again. And this time, we're going to say some float var1. Oh, I put that wrong place. We put in the open and close brace, and then some float var1 goes in there. Okay, so let's go ahead and save it. Always remember to save. Let's build it, and it built just fine. Let's run it. And you can see our 2 values, 123 and 456.78, which is floating point. Now, if I want to, I could, just to show you, I'm going to say some int var1 equals some float var1, and then I'm going to print some int var1. Now, the reason I'm doing this, I want to show you how some int var1 is still going to be an integer. Even though I copy a floating point number into it, it's still going to be an integer. Now, the Rust compiler is actually very verbose when it does the compiler, so we might get a warning message about this. In fact, it even died. The program would not compile because it said you're trying to move a floating point value into an integer value. Now, later on in the course, we'll talk about how to get around that, but for right now, it's telling us, hey, we're not even going to let you do that. C and C++, Java, Python, they let you do all of that. And even though C and C++ and Java are strongly typed languages, what it normally would have done is it would have put the 456.78 into the integer variable, but then just chopped off the 78. Rust won't let you do that. Now there might be a Rust build argument that allows you to do that, but by default, it doesn't allow you to do that. So that shows you how it is very strongly typed. Now, what is the size of each of these variables? I mean, how many bytes does it take? Well, there is a function called size of val, which will actually tell you the size of each of these variables. Now, you're going to see why I'm doing this, but before you're able to do that, you have to include something. You have to tell the compiler that you want to include some more features of the Rust language. So what I'm going to do is I'm going to say use standard mem, and then if I want to get the size of each one of these, I'm going to say, let's just say print ln the size of an int is, and put a double curly bracket just so I can, say that I'm going to add a variable here. And I believe that you would say size of val here. So I'm going to say mem size of val, and you put an ampersand, which means I want to go to the memory address of the variable and say sum int var1. So this will tell you how big it is. Now let's do the same thing with the float. The size of a float, and let's be grammatically correct. And instead of some int var1, I'm going to say some float var1. And let's go ahead and save and build this. And what did I do wrong? It's always good to have an error here. So let's see. Oh, I put the open brace in front of the text that I'm printing. I need to put that open brace only right ahead of the close brace. Yeah, the compiler puts out some pretty good error messages. Oh, I forgot the exclamation mark after the println. Let's go ahead and build it. And there we go. So now it's finished with green. I'm going to run it. And you can see that the default size for a integer is 4 bytes. And the default size of a float is 8 bytes. Now you can override that. And that's what I'm going to show you how to do here. So what I'm going to do here is I'm going to say some int var. And I'm going to say that I don't want it to be a 4-byte integer. I would just like it to be a, let's say, a 1-byte integer. So to do that, I'm going to say, after I say the variable name, I'm going to say colon unsigned 8. U means unsigned 8. That means 8 bits. Now, if you don't know what bits are, I'll put a link to my assembler language data types video. But Rust really doesn't worry too much about data types like C and C++. They use long, short, they use actual words. But in Rust, you actually use a size. You specify the number of bits. So U8 means unsigned integer 8. I could then also say U16. I could say U32. I could say U64. I could even go as high as U128 bits. Now, why would I not just always use 128? Because the more bits, the more accurate the floating point number is, the larger the number is you can have as an integer, because it takes up memory space. And you may not have that much memory. I mean, in modern computers today, I mean, this computer I have right here has 256 gigabytes of RAM memory. So what do I care? Well, but what if I want to sell my application to somebody who's got a little 8 gigabyte computer that they're running all kinds of other applications? I don't want to take up all their memory. So you just want to use what you need. Also, what's unsigned all about? Unsigned means that the number will always be positive. It will never be negative. So let's say if I create a variable called age. So I'm going to say let my age, and I'm going to say I want it to be signed 8 bits. Now, why would I say 8 bits? Well, 8 bits, you have an upper limit of 128, I believe, and a lower limit of negative 127. Will that make sense? Well, I don't know of anybody that's lived longer than that. So maybe that would be fine. So I'm going to say my age equals, I don't know, how old am I? Am I going to lie? Yeah, I'm going to lie. 39. So why use signed? Or actually, I believe it would be an integer. It would just be I. Yes. So I8 means a signed integer of 8 bits. The upper limit is 128 decimal. The lower limit is a negative 127. Can you be a negative age? No. So why would I say signed? In this case, I would say unsigned. This will give me the ability to have an age from 0, which makes complete sense, all the way up to 500 or 255, I believe. So that's a much more than we need, but U8 is the smallest we can do in Rust. So let me go ahead and save this and build it and make sure my syntax is correct, which it is. So this is an unsigned 8-bit integer. What if I wanted to make it a signed? What would be a valid signed? I don't know. Bank balance. I might say integer 8 equals minus $10. I screwed up with one of my checks, so I have an overdraft in my bank account. And so I can have something like that. So when you're creating a variable in Rust, you want to think about what is the variable going to be used for, what are the minimum and maximum values. I'll put some links in my description of this video on that as well. And you want to pick the right size. But notice things are not like they are in other languages where you say int, unsigned int, long, double, short, float, things like that in C and C++. You give it a size because that's what those mean anyway in those other languages. They mean, is it a byte long? Is it 2 bytes long? Is it 4 bytes long? And so forth. So that's what you want to do. Now, what about floats? Well, what would you do with a float? Well, a float's a little bit simpler. I would say I don't know, what would be a good float? Well, bank balance actually isn't good because bank balance, you would actually have dollars and cents, right? So maybe we want to make this a floating point, and the smallest floating point you can have is 32. So you would say float 32. And floating points are always signed. They're never unsigned. They're always signed. What is the size of a floating point? It's huge, right? But really, it's more the decimal point. What is the accuracy of the fractional parts of it? We could also make it a floating point of 64. That makes it a much larger, much more accurate. And I think floating point numbers, you really don't want to use those unless you really need to, because they use a different part of the central processing unit of the computer. It can use up more energy. It makes the CPU hotter. You only want to use floating points when you really need it. Because I've had students say, why don't I just make everything floating point? The other problem with floating points is that they're not stored 100% accurately in the CPU. The integer portion of them are, but the fractional portion are not necessarily stored accurately. Okay, so that's different data types. We talked about unsigned, we talked about signed. We're going to talk about character data in just a moment. But let's also talk about something else that we see here, this let. Well, let's change a value. So down here, I'm going to say sum int var1 equals 0. For some reason, I want to set it to 0. So I'm going to save and build. We have an error. Why do we have an error? It says cannot assign twice to an immutable variable. In Rust, there's this term called immutable, and that means that the variable cannot be modified. Once you create it, once you initialize it, it's basically a constant. So a constant means you can't change it. What if I want to be able to change it later on? Well, you have to use the keyword mut, I call it, but it means mutable. So you put the word mut right after the let, and that means that variable is now changeable later in the program. So I'll go ahead and build it, and now the program built okay. So that's a little bit confusing. Normally it's the other way around. In things like Java, C and C++, you'll actually, everything is mutable. Everything is modifiable in your program, but unless you specify a thing like the word const in C and C++, saying that it's specifically a constant. So it is assumed in Rust that every variable that you create is immutable, is not something that you can change. So that's another thing you want to think about. Do you want to make your variables modifiable? And in this case, I think all of these should be modifiable, right? So I'm just going to say mute in all of these. But the default for the for the Rust compiler is to make everything immutable. So now I can make changes to it. Now, with that said, let's try to put the integer into the floating point number again to see if we still get that error. But before we do that, let's build it and make sure that everything is cool. Okay, and let's see if by making these now mutable, can I do that? Can I say my age equals some float var1? Let's say if I now can copy or put the value of my float var1 into my age. And it still doesn't let me do it. It says that I'm trying to put, and the error is kind of interesting. It said cannot, oh, wait a minute, cannot by some float. Oh, I typed it in wrong. So let's capitalize the V. So it's still not letting me do it. It's saying that you're trying to put a floating point into an unsigned 8-bit integer. So it's still not letting me do it. The compiler is still not letting me try that out. Okay. Something else, whenever you initialize, you always want to initialize it, whether you make it 0, whether you make it a value, you just definitely want to do that. All right. So now the next thing I'd like to talk about is I'd like to talk about another data type, which are Booleans. So what I can do is there's another data type, which is a Boolean, which either has a true or a false value. So I'm going to say let mute in pain, I'm not sure why I'm saying that, equals true. So true means that I am in pain, false means I'm not. So if I say true, or I can say false. Now these are mainly used, I don't know if you've ever seen on web pages where they have a little checkbox or something. That's normally used as a Boolean, right, where it's checked or not checked. It either has 1 or 2 values. Let's see if it'll build okay. And yep, I still have this error here. So let's go down here and get rid of that error. And I think it says false here. So let's make that false, save it, and build it. And it built it okay. Well, we've got some warnings here. A lot of the warnings in Rust are mainly about programming standards, like you're not using snake case, or you should do something else. We'll talk about that later on as the course moves on. So there you go. So we're able to move 0 into some int var. We've got our mutable in pain Boolean. So the next thing I want to talk about is I want to talk about strings. Now, there's really 2 types of strings in Rust. There's a C string type string, which is an array of characters. That is different than the string data type. So for instance, let's create a string. Let's create a C string, an array of characters called my first name, and I'm going to make that equal to Bill. Also notice that I have a semicolon at the end of each line. That's like a lot of languages like C and C++ and Java. So what this is doing is this is actually not creating a string. It's creating an array. It's creating a table, a list of single character chars, and it's assigning that location in memory to the variable my first name. So we're going to talk more about C strings and how to go through them. And maybe C string is the wrong term in Rust, but that's the term that a lot of people use in C and C++. Then there's also a thing called a string data type. So to do that, I'm going to say let my last name, I want to make that a string of data type from a C string. So let's talk a little bit about what I'm doing here. So what I'm doing here is I'm saying I want to create a data type string. I want to create a variable of data type string, and I want to name that variable my last name. I want to make it equal to a string data type executing the function from this C string. That's one way of doing it. Another way of doing it, I'm going to say let my address and I'm not even going to say colon string. I'm just going to, because I'm going to let the compiler do that for me. I'm going to say 1, 2, 3, 4, 5, I don't know, drive, and I'm going to say dot to underscore string. That's another way of creating a string. So we're going to have a whole video on strings and C strings, but this is a way to do it. Now these are immutable, right? So you really might want to put mute here, saying that they're mutable. Let's go ahead and save and build that. And it said it couldn't compile it, so let's find our error. Looks like I probably forgot something here. So mute my, I forgot the equal sign. Look at how simple that is. There we go. Okay, so now it compiled. So again, remember, just for the introduction to variables, a string and a char array, or a set of characters, I like to call them C strings. those are two different things. I think most people will use the string structure because it will dynamically get bigger or smaller. You can assign new values to it. Like let's say this, I'm going to say my address. Let's say I move my address equals 89876 Funny Road. I can do that. I can say take this C string, take this set of characters, convert it to a string, and assign it to my address because my address is a string as well. I could have said this as well, which is the way I like to code. I always like to specify the data type in Rust because it's kind of the same. You have to do the same thing in C and C++, but it gives you the option to do that. So now it's going to replace my address with that. Let's build it. Oh, what happened? Oh, I have a capital S here. So let's make it a lowercase s. That's important. I'm glad that happened because case matters in Rust, just like it does in C and C++. Okay, good. So I've got that. Now let's go ahead and print. Let's print. Println. And we're going to say my address. So we're going to print it before we change its value. And let's print it after we change its value. Okay, so you can see right here that before we changed its value, it was 2345 I don't know drive, and after we change its value, it's now 9876. So we were actually able to change it. What if we wanted to change a non-string, a C string? What if we wanted to change that? We're going to get into that when we actually get into C strings, when we get into arrays. So I'm going to show you how to do all that when we get there. All right, so that is an overview of creating variables in your program. It's the first thing you're going to want to do before you actually start coding. You need to figure out what variables you need to get the work done that your program has to do. And we're going to talk more about print in the next video. But also take a look at the description of this video because I've got all of the different data types that you can create variables for in Rust. Maybe not all of them, but some of the most commonly used ones. And like I said a moment ago, we're going to talk about printing data, how to format it, how to really do some really cool things with print. Also how to do things with a format command, which allows you to take a lot of data and put it into a string variable. Hope to see you at that next video.